So, as a way of sustainable water management, we need to include some non-conventional approaches, as I mentioned. Conventional sources would be right now we are using dams as storage for water and or reservoir, and then some lakes and rivers as a natural reservoir as well. But there are some non-conventional or unconventional approaches, and these are water reclamation or wastewater reuse and seawater desalination. So the sources will be from wastewater, and we are turning wastewater into something useful. So we're reusing the wastewater and make it into useful water. And so the quality of the wastewater will be improved based on new technologies. And the other one is seawater desalination, because as we all know, seawater has a very big. We have a very big amount of seawater in the world. So why not use this resource in order to provide some potable or non-potable use? So let's start with wastewater reuse. So water reuse or wastewater reuse is the use of treated wastewater for beneficial uses. So it means that the key here is beneficial. So it really depends on your end use. So the quality of the produced water from the treatment plant, for example, this is a wastewater treatment plant. It depends on what kind of end use you are going to do. For example, for washing or flushing or irrigation, cooling. So the quality will also depend on that one. We don't really need an A grade quality if we are only using for this kind of purposes, because they are what we call as out of body use. But if we are referring to drinking water, for example, of course, we have different standards for each one, and drinking water is the highest standard that we need to have as a water quality. So this is an A grade for this. The rest should be lower than the quality of drinking water, but should pass the standards on specific uses of this water. The wastewater, and this is more problematic compared to seawater, because when we say wastewater, it is composed of a lot of dirty things, including biological, chemical, and physical aspects. So the wastewater before was considered to be a disposal problem, especially in the 1980s. They don't see any value to the wastewater, and so cities want to just to get rid of it on a more regular basis. But after some time, the people have realized that in fact, with proper treatment, the bulk of the wastewater is actually water, and the rest are solids. So with proper treatment, it can really be a good source of recycled water for many different purposes, not only for non-potable purposes, but even for potable purposes up to this point, depending on the technology. So the advancements of technology has enabled to have this treatment. The term used are water reclamation and water reuse. Basically, it refers to treating and managing of this wastewater to produce something that can be productively reused. So for depending on the end use or end use application. In the issue of on the topic of potable reuse concept, so this is basically talking about the highest grade of water possible from the treatment process. So there are two kinds. We can divide that one into two kinds of process, DPR and IPR. So DPR stands for direct potable reuse, and the other one is indirect potable reuse. So indirect potable reuse is basically based on nature. So in natural setting that we have, once we have a water that we use, it goes towards the natural system, for example, and it goes to an environmental buffer like a reservoir or lake, and the lake will perform a purification process like sedimentation, but it will take very, very long time. So it takes long time for the natural process to do, and then from that lake or from that reservoir, it goes towards the water treatment and goes back to the use of that water. So that indirect potable reuse is in fact what is the nature, is based on nature. But because of we have technologies now, so what happens for using the technology is it just accelerates the process compared to the natural process. So for indirect potable reuse, basically after using the water from the urban use, like the houses, the buildings, and in the cities, the wastewater will now go to the wastewater treatment plant. And after the wastewater treatment, it goes towards the wastewater treatment plant, and then it goes towards an advanced water treatment plant, then disinfection, and then after getting the quality required here, it goes towards the buffer. This is for indirect potable reuse. So the water that's coming from here goes towards a buffer, environmental buffer, just like a natural system, like a lake or a river or some natural reservoir. And then the natural reservoir will stay there for some time, and then the water is being collected now and supplied to a water treatment plant. So this process from here to here is much shorter compared to the natural process of buffering and purification. So now it goes to the water treatment plant, and the water is treated to the level of safety for use, and it goes back to the houses and civilization. If compared to this case, the DPR, direct potable reuse, omits this situation here. This is deleted now. So instead of going to the buffer, so after this treatment process, it goes towards directly to the water treatment plant. Sometimes there is an engineered buffer for a very short time, but in normal cases, in many cases, it goes towards the water treatment plant, and then the water is treated and then goes back to direct use of the water. That's why it means that direct potable reuse is like this, a shortcut compared to this one. Of course, you have a better technology to be used in this case as well. So the direct potable reuse is what is given in your scenario in your task one. So the task one scenario was, if you are to propose, if it is proposed that a direct potable reuse to be built in Sydney, you have to analyze, do a SWOT analysis about that, take about the advantages and disadvantages, and do a stakeholder engagement based on direct potable reuse situation. Okay. So why do we do water reuse? What are the drivers of doing so? Basically, it can be divided into economic, talking about money, environment, and social aspects. So economic-wise, it's a cost-effective supply because the source is a wastewater anyway. And so the water quality that is coming from the treated water or the reused water can be, the purpose could be fit on whatever it is the application for industry, like cleaning, for urban applications as well. It doesn't need to be drinking water quality anymore, so it's very cost effective. Economic value towards especially agriculture, because agriculture uses a lot of water, so it means that instead of using high quality water for agriculture, we can now produce water on the can be now produced depending on the quality that is needed for agriculture. The environment, of course, is a reduced demand on the drinking water sources. As I mentioned, instead of using this drinking water for other purposes, we can just focus this one just for drinking. The water that is coming from our wastewater treatment plant as a reused water reuse is reducing the demand for the drinking water. It can also reduce wastewater treatment plant pollutant loads and improve our overall environmental flows, because of course we are treating the wastewater into a good quality. In social one, sometimes it can increase the amenity value of your place. Like example, irrigation of homes and sports field, meaning that if you are practicing sustainability, people will see it in a positive way, and so it also increases the value of your location. The recreational areas as well, new recreational areas. The dams, for example, or not the dams, but the wetlands and other water recycling infrastructure could be a tourist spot or places to visit. And also beside that, those places could be a place for recreation and a general community support for the sustainability aspect of reduce, reuse, recycle concepts. So this is more of a green living way, so it is positively accepted by community. And so if you look at the various applications of the for water reuse, you can see a lot of applications in different areas, coming from the recharge basins to going towards the farm, towards the well, towards some factory, towards the city. And so it's giving a lot of value. The water reuse process, or the reuse of water, is giving value to our wastewater as a further resource of new water. Of course, with the use of wastewater, it doesn't really come without a price, because wastewater is still at stage of a raw sewage is very dirty. And so that perception stays there in the mind of many people. And because of that dirty perception, it relates towards the presence of bacteria, some pathogens there that can result to diseases, for example, or the presence of heavy metals, the presence of these different metals here: lead, copper, cadmium, arsenic, and these are all dangerous ones at different concentrations, and it will lead to some toxic reaction to the body. And also there is a concern about food safety, about the use of that reused water into the preparation of food is as a factor that may affect, they're saying that it will pollute the food as well, and make as using as the quality of that water is not good enough. And also the psychological issue about yuck or disgust image is a very big issue for the use of reused water. And most of these things, all of these things will be discussed in our next video about identifying the different factors of community acceptance. And these are really some of the big factors to consider. And so one of the technologies that used for, especially for potable wastewater reuse technology, is a multi-barrier treatment system. So the multi-barrier treatment system ensures that all the possible pollutants or contaminants inside the wastewater are treated, or actually not allowed to pass or to be present in the produced water or the potable water. So for example, if we have a sewage water here, it has different barriers. So it is barrier number 1, 2, 3, 4, and 5. So this is a multi-barrier system. So in this case, from big things and some other things that don't pass through the membrane, they are segregated here, separated by the use of a membrane. And then whatever that passed through the membrane will again be destroyed by a UV disinfection part here. And then it goes towards a reverse osmosis process, which uses a much is a dense membrane that only allows water molecules to pass through. Of course, there are some that are quite small things that can pass through as well, but then there's another barrier system that would enable to further reduce whatever contaminants you have in that water at this stage. And then lastly, it will go towards, if there are bacteria still here, then it will go towards a more disinfection process before it goes to being a potable water. So there are still some mixing of minerals here, some changing the pH and all, but this part here should be at a quality that is acceptable in the standard, like the World Health Organization standard or the Australian Drinking Water Standard. Okay, so this is a way of using mainly membranes, membrane systems for this. So in our class, we will be using a process called membrane bioreactor to treat the wastewater, and reverse osmosis is used for desalination. And this will be further discussed in your module 2 or block 2 class, and also in block 3 class. So other factors to consider for water reuse is basically the time of its application. So the timely move towards the public. So what's the motivation? So if you are saying that the time is during a drought, then most likely this this project of or water reuse system will be accepted by the public. But if you are going towards the public at a time that water is just overflowing and we have a lot of rain, we don't have problems with water, then that could be another issue in terms of acceptance of the public. And this is related to one in the level of stress. So the time of this would be perfect for that. But of course, we don't want to just wait on the situation where water is a problem now. There should be a condition, a special consideration to community attitudes and their concerns to use of recycled water. We need to make sure that people understand the quality of the water and that all their concerns are addressed properly in a way that it will be safe for them, it stays safe for their children. The name doesn't really trigger something that is dirty, so the branding is important. And there's also need for a factor for public awareness of the availability of other alternative water sources and the potential of the reuse scheme. So we need to show them that the technology is working. It's a proven technology. Water quality wise is good, and so we have to find a strategy to make them aware of these things, and also make them aware of the situation of Australia, that we are a dry nation and we need to really make sure that we are secured in our water. Need community acceptance achieved by social marketing and public outreach. So this will come in our stakeholder engagement or the social license to operate. We need to have that full acceptance for the community. The variety of end uses available for recycled water. So it means that we can explain to the public that each application will have their own requirement for their water quality. So it doesn't mean that the drinking water quality is needed for all applications or all uses. So we can reduce the quality depending on the end use. And of course, the cost of the recycled water is also a factor for consideration. And many people think that reused water should be cheaper than the other water because of where it come from. So these are the different factors to consider for water.